Okay. For 2, you no longer need 6 things. You no longer need 3 sets of angles and 3 sets of sides to prove 2 triangles are congruent, because there are situations where there is no other option. It must be congruent if this scenario works out, okay? The first of those is called side, 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 which you may write as SSS every time. Okay, so the side, side, side postulate says if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. Hello, Lily. We just started 4-2 notes, so you haven't missed much. So you have these 2 triangles here. Yesterday, we said, okay, we know the 3 sets of sides are congruent. Now we've got to prove that all 3 sets of angles are congruent to know those triangles are congruent. But if the 3 sides of a triangle are congruent to another 3 sides, then the angles must be. So we don't have to prove it anymore, because brilliant mathematicians back in the day proved it for us. So now we would say triangle ABC is congruent to triangle DEF by SSS, by the side, side, side postulate. Because we have 3 sides congruent to 3 sides, they are congruent, okay? Here's why this works. Triangles are what we call rigid figures. If I were to take a triangle and push on this top part of it, if it moves, it is not the same length sides anymore, right? If I shifted the triangle, it's going to change the lengths of my sides of my triangle, because it is a rigid figure. That is the only triangle that you can make with those 3 side lengths, okay? Could you name a figure that's not a rigid figure? Is there a figure that if you pushed on it, it'll just make a different figure but with all the same side lengths? A square would be one, right? If I took a square and I just pushed on the top of it, my angles would change, right? But my side lengths would all be the same, okay? A square is not a rigid figure. A square, a rectangle, any 4-sided parallelogram really would be not a rigid figure. But a triangle is a rigid figure. So you cannot push on a side and get the same 3 side lengths. Therefore, if you have 3 side lengths that match up with 3 side lengths, there is only one triangle you can make, okay? It might flip or turn or twist around, but it's the same congruent triangle, okay? So that's why SSS works. So let's take a look at what an SSS proof might look like. When you do a proof, here's what you want to do. And I'm going to sound like a broken record because I'm going to keep saying the same things over and over and over again. But it's going to be good because you're going to get there in the end and you're going to just rock these proofs. When you do a proof, you will always get a picture, okay? We want to look at that picture. We want to mark up what we know about it. Chances are they have marked something for you. So your given information is LM is congruent to NP. That's marked for you. LP is congruent to MN, also marked for you. They want us to prove that these 2 triangles are congruent. Where do we start? With the given. This information goes right here, and we call it given because they gave us all of that. Now, if we're trying to prove 2 triangles congruent, we know 2 ways to do that. Name all 6 corresponding pieces, or name what? 3 corresponding sides that are congruent, right? SSS proves triangles congruent. Does anyone see a way that we can say SSS will work? That third side that we don't know yet is the same side. So LN on the top triangle is congruent to LN on the bottom triangle because it is reflexive. It's the same segment. So now look at your triangles. You have a side that corresponds to a side that corresponds to a side, and a side that corresponds to a side, and they're all congruent. So what can we say? You can say what they asked you to prove. Triangle LMN is congruent to triangle NPL by what? Side, side, side. If you have three sets of sides congruent to three sets of sides, that is the SSS postulate. The triangles will be congruent. Any questions on that? Was that proof a little bit easier? It's getting a little easier, right? It's getting a little easier. Okay, next one. Okay, you need to understand what an included angle is for this next piece, okay? Tell me what it means to be included. Like if you were included in something, you were what? Part of it. Like you're right in the mix, right? You are included. An included angle is an angle that's right in between two sides, okay? So if I'm using this side and this side in a proof, can anyone tell me which angle you think is the included angle? Angle A. It's the angle between those two sides. You have these sides, so angle A would be our included angle, okay? If I were using, you don't have to draw this, but just one more for good measure. Let's say I had this triangle, and I was going to use this side and that side. What's my included angle? Angle Y. Okay, so understanding that, there is this SAS postulate, and you can see it in the name, right? It's a side, the included angle, and a side, the angle between our two sides. So SAS, side, angle, side, says if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then those triangles will be congruent. There is no way around it. If you see SAS and SAS, those triangles must be congruent. Okay, again, isn't that lovely? We only have to prove three things instead of all six. Three sides, three angles. We don't have to do that anymore. So if you look at this picture, we could say triangle, if I say triangle BAC, what triangle is that congruent to? EDF. If I say BAC, then I have to name it EDF. Okay, so you have to match up the corresponding parts. EDF by what? SAS, side, angle, side. I have a side that corresponds to a side that corresponds to a side, and then the included angle in both of those, the angle that falls between those two sides. Okay. So take a look at this picture. It says, what other information do you need to be able to prove these two triangles are congruent by side, angle, side? Now, just because something isn't marked for you doesn't mean it's not true. There's something you know here that's not marked, but we know to be true. What do we know to be true here? We don't know they're parallel. We don't know ED and FG are congruent. What do we know about these two triangles?
They have a same line.
Yes, they have a same line. They have a reflexive side, right? So without being told, we know those are congruent. this is saying, prove to me by SAS that these are congruent. What other info would we need to be able to say side, angle, side? Is it a side or an angle, first of all? It's an angle, right? Because right now we have side and side with side and side. So we need which angle? The included angle. We need the angle between those two sides. So is that angle GFD or angle GDF? GFD or GDF? It can't be both. It's either this or it's this. Which one's the included? GDF. It's the first one, right? It's this guy. Because you have side and side, the included angle. So just look at the one triangle. The included angle is the one between them. So we would have to know that angle GDF is congruent to angle what? What's the other included angle? EFD or DFE. So the other information we would need to know is that those are congruent. Why don't we know that right now? Because a lot of you would probably say, we know that. But why don't we actually know it? What didn't they tell us? They've not told us that the lines are what? Parallel. If they don't tell you the lines are parallel, then you don't know the angles are congruent by AIA, okay? So we would need to know that these two angles are congruent, and then we could say SAS, okay? Okay, there is an entire page on your test for chapter 4 that is just these. Tell me which triangles are congruent by which postulate. Right now, we've only learned SSS and SAS. So you're either going to tell me this is SSS, this is SAS, or NEI means not enough info. We just don't know. They might be, but we don't know. Okay? So take a look at letter A here. Can you tell me that those two triangles are congruent?
Yes.
Okay, so then we're going to write a congruent statement. If I say triangle, I'm going to say BCA. Be careful here. Which triangle is BCA congruent to? Not ZYX. I started at B. I went through the single mark and then the triple. So through the single, through the triple would be YZX. Okay, so make sure you name them appropriately, the matching parts. By what? Which congruence theorem? This is SSS, side, side, side. A side that corresponds to a side that corresponds to a side, and a side that corresponds to a side. All right, look at letter B. Are those two triangles congruent? Yes? Who thinks yes, these are congruent? Who thinks no, these are not congruent? I saw lots of yeses and then a lot of not raised hands. Why do you think these are congruent? Which postulate would say they are? SAS. You have a side that corresponds to a side, another side that corresponds to a side, and then it's the included angle and the included angle. So those are congruent by SAS. Now be careful how you name it. What triangle is congruent to what triangle? If I say ACB, what is ACB congruent to? QPR, right? If I started at A, there's no marking there. I went through the single mark to the double. So through the single to the double would be QPR. Okay? By side, angle, side. So that's your congruent statement. When it asks you for a congruent statement, it's which triangles are congruent by which postulate. Okay? Okay. Take a look at this one. Are your triangles congruent?
Yes.
By what? SSS. Okay. Pretend you don't have these. Are the triangles congruent?
Yes.
Why?
Third.
Not third angles theorem. What'd you say? Why SAS? What angle do you know? You have vertical angles, right? What do you know about vertical angles? They're congruent. So this angle is congruent to this angle. Was it marked for you? Is it true? Yes. So even though it's not marked for you, it's still true. Vertical angles are always congruent. Okay, so this one technically, if you had just started with it as it was, you could say SSS or you could say SAS and they'd both be correct. Okay, let's name it. Triangle, if I say ACB, what triangle is that congruent to? ECD. By, and now you may say SSS or you could say SAS if you want to use the vertical angles instead. Okay? Okay. Last one of these. Are these two triangles congruent? Why? SAS?
No. Oh, no. Oh, no. It's different.
You have a side that corresponds to a side that corresponds to the side. The included angle, what's the included angle over here? The included angle would be that one, right? This is where you get to swear at your teacher. You actually don't get to because it doesn't exist. This would be donkey theorem, right? We call it the donkey. That doesn't exist, okay? So if you ever see ass on your paper, yep, I know I said it. If you ever see that, think, I shouldn't swear at my teacher. It must be wrong, right? Yes, okay. So this is the included angle. This is the non-included angle. Therefore, these might be congruent, but we don't have enough information. Okay, they are not matching up, so this is not enough info. Good on that? Okay. We're gonna save this. Are we gonna save that for tomorrow?
Yeah, I think so. I agree.
You think so?
Hardly already.
I think
How about let's do one, because we didn't do a proof. We didn't do a proof. Well, we did one proof. Let's just do one. Pick one. Which one do you want to do?
It's okay.
Number 9?
Oh, yeah, that's it.
Okay. This one says, given all of this information. Oh, it's a good pick. I liked this pick. Notice what they marked for you. So they marked these two things. This is not marked. It says F is the midpoint of GI. Okay. Where do you start? What's your first step?
Given.
The given. This information goes here. Now, they tell you stuff for a reason. Okay. So everything's been marked from here. This has not been marked. So why in the world did they tell it to you? Why are they telling you F is the midpoint of GI? It does have to be marked to be true, but they're telling it to you so that you can mark something. What does this tell you? F is the midpoint of GI.
They're congruent.
What are congruent?
The triangles.
Nope.
No, the line.
What lines?
G,
What?
like, GF.
There you go. because they told me F is the midpoint, I know that IF is congruent to FG, okay? Whatever they tell you is for a reason. Whatever they give you that information so that you know something else, okay? They told us it was a midpoint. So now I can say they are congruent by the definition of a midpoint, right? A midpoint makes two equal segments. So because I know the definition of a midpoint, I know those two segments are congruent. So whenever you see the word midpoint in a given, I promise you're going to use the definition of a midpoint somewhere in your proof, okay? Okay, so now what can we say? This is your last step.
EFI equals H.
Say what they asked you to prove. The triangles are congruent by what?
SS.
SSS. Side with side, side with side, side with side. SSS. It's good stuff, right?